Scientists have found the strongest evidence yet that a planet 124 light years away could be home to life.
Scientists have just uncovered the strongest evidence yet.
We found the strongest evidence to date on a biosignature molecule, in this case a combination, potentially around another star outside the solar system.
That life might exist on a distant planet before light years away. This could be the biggest discovery of the century, and it's sending shockwaves through the scientific community. The planet, known as K218b, is teeming with possibilities, with signs pointing to biological molecules that suggest, yes, life could actually exist beyond Earth. The only question now is, are we finally about to answer one of the universe's oldest mysteries? Keep watching, because what we're about to reveal could change everything you thought you knew about life in space. The quest for extraterrestrial life, a journey through space and time. For centuries, humanity has dreamed of life beyond our planet. We've looked up at the stars, wondered if there are other civilizations out there, and speculated about the vastness of the universe and whether life can exist elsewhere. From ancient philosophers to modern scientists, the question has always been, are we alone in the universe? The idea of extraterrestrial life has fascinated cultures for millennia, but it was only in the last century that humans began to seriously search for answers. This search for life beyond Earth has driven space exploration, the search for exoplanets, and our understanding of the universe. It's a question that has intrigued astronomers, philosophers, and even world leaders. The idea that there could be life beyond Earth in distant star systems is a tantalizing possibility. For the last few decades, scientists have focused their attention on planets that orbit distant stars, known as exoplanets. These planets, which exist outside our solar system, have been found to have characteristics that could support life, such as water, a stable atmosphere, and the right chemical ingredients. The discovery of exoplanets has been a major milestone in our search for extraterrestrial life. In fact, astronomers have now found thousands of exoplanets, many of which are located in the habitable zone of their stars. The habitable zone, also known as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist, considered one of the key ingredients for life as we know it. This makes these planets prime candidates in the search for life. The James Webb Space Telescope, JWST, which was launched in 2021, has been a game-changer in this search. With its advanced infrared capabilities, it allows scientists to peer deeper into the cosmos and gather unprecedented data about distant planets. It is this cutting-edge technology that has enabled the detection of K218b, a planet located in the habitable zone of its star 124 light-years away. The detection of K218b is exciting because it represents the best evidence yet of the potential for life on a distant world. The planet is approximately 2.5 times the size of Earth, and it's considered a super-Earth, a planet that is larger than our own, but still within the realm of possibility for supporting life. K218b's location in the habitable zone of its star means that it has the right conditions to support liquid water, a key ingredient for life. One of the most intriguing aspects of this discovery is that the James Webb Space Telescope detected molecules in the atmosphere of K218b that are typically associated with life on Earth. These molecules include dimethyl sulfide, DMS, a gas produced by marine microbes on our planet. DMS is found in the oceans of Earth and is associated with biological processes. The fact that this molecule has been detected in the atmosphere of K218b raises the exciting possibility that the planet could be home to life. However, while the detection of DMS is an exciting breakthrough, it is not yet definitive proof of life. The presence of this gas is a strong indication that life could exist on K218b, but scientists are cautious. They need more data to confirm the findings. It's possible the DMS could be produced by non-biological processes, such as volcanic activity or atmospheric chemistry, but the fact that the molecule is commonly produced by marine life on Earth makes the possibility of life on K218b a tantalizing one. The discovery of DMS on K218b is significant because it marks the first time scientists have found a potential biosignature on a planet beyond our solar system. A biosignature is a molecule or chemical compound that provides evidence of life. On Earth, scientists use biosignatures to detect the presence of life in extreme environments. And now, thanks to the James Webb Space Telescope, we are seeing potential biosignatures on a distant exoplanet. This discovery is a major step forward in our quest to answer one of humanity's oldest questions. Are we alone in the universe? If K28b is confirmed to host life, it would have profound implications for our understanding of biology, chemistry, and the nature of life itself. It would suggest that life is not unique to Earth, but rather a common occurrence in the universe. The possibility that life could exist elsewhere in the galaxy opens up new frontiers of scientific exploration and raises important philosophical questions about our place in the cosmos. The search for life beyond Earth is not a new endeavor. For centuries, humanity has wondered if we are the only intelligent beings in the universe. In the 20th century, the discovery of radio signals from distant stars sparked excitement about the possibility of extraterrestrial intelligence. The SETI, Search for Extraterrestrial Intelligence program, was established to search for signs of intelligent life, such as radio signals or other forms of communication from other civilizations. While SETI has yet to detect any definitive signals, the search continues. The discovery of exoplanets in the 1990s was a major milestone in the search for life. The first exoplanets were discovered by Michel Mayor and Didier Queloz in 1995, and since then, thousands of exoplanets have been identified. Many of these planets are located in the habitable zone of their stars, where the conditions for liquid water are present. These discoveries have fueled optimism about the possibility of life beyond Earth. In recent years, astronomers have turned their attention to studying the atmospheres of exoplanets. By analyzing the light that passes through the atmosphere of a planet, scientists can determine the chemical composition of the atmosphere. This allows them to identify molecules that could be associated with life. In addition to DMS, other molecules such as oxygen, methane, and carbon dioxide have been detected in the atmospheres of exoplanets, raising the possibility that some of these worlds could be habitable. The James Webb Space Telescope is playing a crucial role in this search. With its advanced technology, it can detect molecules in the atmospheres of exoplanets with unprecedented precision. Webb's ability to study the chemical composition of distant planets is revolutionizing the search for life, and the discovery of DMS on K218b is just the beginning. But the search for life on other planets is not without its challenges. The distances involved are vast. K218b is 124 light-years away, which means that the light we see from the planet today left the star over a century ago. This makes it incredibly difficult to study these distant worlds in detail. The data we're receiving from the James Webb Space Telescope is only the beginning, and scientists will need more time and more observations to confirm whether K218b truly harbors life. Despite the challenges, the discovery of potential biosignatures on K218b is a huge step forward in our search for extraterrestrial life. It shows that the tools and technologies we have today are allowing us to explore the universe in ways we could only dream of just a few decades ago. As the search for life continues, the findings from K218b will play a crucial role in shaping our understanding of the cosmos. This discovery also raises important questions about the future of space exploration. If K218b is confirmed to support life, it could inspire new missions to study the planet in greater detail. It could also open up new possibilities for future exploration of other potentially habitable exoplanets. The discovery of life beyond Earth would undoubtedly be one of the greatest scientific achievements of all time, and it could change the way we think about our place in the universe. But are we ready for the implications of this discovery? Could we be on the brink of a new era of space exploration and scientific understanding? The discovery that could change everything, K218b's potential for life. The universe is an incredibly vast and mysterious place, and for centuries we have gazed up at the stars, wondering if we are truly alone. The search for extraterrestrial life has captivated scientists, astronomers, and ordinary people alike. With each new discovery of distant planets, the hope that we may not be the only sentient beings in the universe grows stronger. But even with all of our advancements in technology and knowledge, the question of life beyond Earth has remained elusive. That is, until recently. In an unprecedented breakthrough, scientists have discovered what may be the strongest evidence yet of extraterrestrial life on a distant planet. The discovery was made on a planet called K28b, a world that is located 124 light-years away from Earth. This discovery is exciting for many reasons, but perhaps the most intriguing aspect is that K218b is in the habitable zone of its star, meaning that conditions there may be just right for life to exist. This revelation has sent shockwaves through the scientific community, and the implications of this finding could be revolutionary. K218b is a super-Earth, meaning that it is larger than our own planet. It is approximately 2.5 times the size of Earth, which makes it an ideal candidate for study in the search for life beyond our world. The planet is believed to be a water world, with vast oceans covering much of its surface. This is important because water is one of the key ingredients for life as we know it. The presence of liquid water on a planet is one of the most significant factors in determining its potential for supporting life. The discovery was made possible by the James Webb Space Telescope, the most powerful telescope ever built by humanity. The James Webb Space Telescope has allowed scientists to peer deeper into the universe than ever before, and its advanced capabilities have made it possible to analyze the chemical composition of exoplanet atmospheres with unprecedented precision. It was this technology that enabled scientists to detect molecules in K218b's atmosphere that are typically associated with life on Earth. One of the key molecules detected on K28b is dimethyl sulfide, DMS. DMS is a gas produced by marine microorganisms here on Earth, particularly plankton in the oceans. The fact that this molecule was detected in the atmosphere of K28b is highly significant because it is a compound that is typically found in environments where life exists. The presence of DMS suggests that there could be biological activity happening on K218b, potentially in its vast oceans. This is the strongest indication yet that K28b could be home to life. But while this discovery is incredibly exciting, scientists are cautious. They know that the detection of DMS alone is not definitive proof of life. There could be other, non-biological processes that produce DMS. For example, volcanic activity or complex chemical reactions in the atmosphere could theoretically produce the same molecule. As a result, scientists are careful not to jump to conclusions and are continuing their research into the possible origins of the molecule. However, the fact that DMS is produced by life on Earth is a compelling argument that life could exist on K218b. This discovery represents a pivotal moment in the search for life beyond Earth. For the first time, scientists have found a potential biosignature on a planet outside our solar system. A biosignature is a chemical or physical characteristic that is indicative of life. For years, scientists have been searching for signs of life on distant exoplanets, and the discovery of DMS on K218b is one of the strongest pieces of evidence yet. The implications of this discovery are profound. If K218b is confirmed to harbor life, it would change our understanding of the universe and our place in it. It would suggest that life is not unique to Earth, but rather a common occurrence in the galaxy. The idea that life could be widespread across the universe opens up new possibilities for exploration and scientific discovery. It also raises profound philosophical questions about the nature of life, intelligence, and the potential for interstellar communication. But, as with any major scientific discovery, there is still much to learn. While the evidence for life on K218b is compelling, it is not yet conclusive. Scientists are continuing to gather data and will need more observations to confirm the presence of DMS and other potential biosignatures. The James Webb Space Telescope will continue to study K218b and other exoplanets, and new missions to explore distant planets could provide even more answers. One of the challenges of studying distant planets is the vast distances involved. K28b is located 124 light-years away, which is an almost incomprehensible distance. Even with the most advanced technology, it takes years for light from distant stars and planets to reach us. This means that the light we are receiving from K21b today left the planet over a century ago. The data we're receiving now is just the beginning of a long process of studying the planet and its potential for life. The detection of DMS on K218b is just the first step in a much larger effort to study exoplanets for signs of life. While K218b is a promising candidate, it is not the only planet that scientists are focusing on. In the coming years, astronomers will continue to study other exoplanets in the habitable zone of their stars, looking for signs of life and other biosignatures. The search for life beyond Earth is only just beginning, and K28b is an important part of that journey. One of the most exciting aspects of this discovery is the possibility that life could be found on a planet that is very different from Earth. K218b is a water world, and the conditions there may be radically different from anything we've experienced. This raises the question, what forms of life could exist in such an environment? Could there be life forms that are radically different from anything we've seen on Earth? The discovery of DMS is just the beginning, and the possibilities for what could be found on K218b are limitless. The potential for life on K218b also raises questions about how we might communicate with extraterrestrial civilizations should they exist. If there is life on K218b, it could be radically different from life on Earth. Would we even recognize it as life? How would we make contact with beings from another world? These are questions that humanity has been asking for centuries, and the discovery of DMS on K218b brings us one step closer to answering them. As we continue to explore the universe and search for life beyond Earth, the discovery of K218b and its potential biosignatures is a thrilling development. The next few years will be crucial in confirming whether life exists on K218b, and if so, what that means for humanity's place in the cosmos. Could this be the beginning of a new era of exploration, discovery, and perhaps even contact with extraterrestrial life? Could this be the moment we've all been waiting for? The moment that proves we are not alone in the universe? What the James Webb Space Telescope reveals. The discovery of potential biosignatures on planet K218b has taken the search for extraterrestrial life to new heights. For years, scientists have wondered if life exists beyond Earth. And now, with the detection of dimethyl sulfide, DMS, in the atmosphere of a distant exoplanet, we are closer to answering this question. What makes this breakthrough even more exciting is the technology behind it. The James Webb Space Telescope, JWST, which played a crucial role in making this discovery. The JWST, the most advanced space observatory ever built, is capable of observing distant exoplanets in ways that were previously impossible. Unlike the Hubble Space Telescope, which only observed ultraviolet and optical wavelengths, the JWST specializes in infrared wavelengths. This allows it to peer through dust clouds that obscure visible light and analyze the chemical composition of exoplanet atmospheres. It was this ability that enabled scientists to detect DMS on K218b, an indication that life may exist on this distant world. K218b, located 124 light-years away, is about 2.5 times the size of Earth and orbits a star similar to our Sun. While scientists had long suspected that the planet could have conditions suitable for life, the detection of DMS was a game-changer. On Earth, DMS is produced by marine microorganisms like plankton, and its presence on K218b suggests that if life exists there, it could resemble marine life on Earth. This is an exciting possibility, as it implies that life could be more common in the universe than we once thought. While the discovery is groundbreaking, scientists remain cautious. They acknowledge that more data is needed to confirm that the DMS is of biological origin. The universe is full of strange processes that could mimic biological signatures, so scientists want to ensure that the DMS found on K2-U8b is truly the result of life. Nonetheless, the evidence gathered so far is strong enough to generate optimism in the scientific community. The JWST's capabilities go far beyond detecting DMS. It can also study the chemical composition of K2-18b's atmosphere in great detail. By analyzing the way light passes through the planet's atmosphere, scientists can identify gases like carbon dioxide, methane, and water vapor, gases often associated with biological processes. The JWST's ability to measure these gases with precision makes it an invaluable tool in the search for life beyond Earth. If other gases linked to biological activity are found on K2-18b, it would further support the case for life. Although scientists are still working to confirm the presence of these gases, the detection of DMS alone is already a promising sign. The JWST has proven to be an indispensable tool in studying exoplanets, and its ability to detect biosignatures is already shaping the future of astrobiology. The JWST's mission is just beginning, and it will continue to observe exoplanets like K2-18b in the coming years. As the telescope gathers more data, scientists will refine their understanding of the planet's atmosphere and its potential for hosting life. This is only the first step in a much larger process of discovery that will ultimately lead to a better understanding of life in the universe. In addition to finding biosignatures on K2-18b, the JWST will continue to study other planets to search for signs of life. The telescope's ability to study exoplanets in such detail gives us hope that we may one day find life beyond Earth. With the JWST leading the way, the future of space exploration has never been more exciting. While the evidence for life on K2-18b is still tentative, the detection of DMS is one of the strongest signs we've had yet. More data is needed, and scientists will continue to observe the planet over the next few years. If the findings are confirmed, it would mark a monumental breakthrough in our understanding of life beyond Earth, and it could change the way we view the universe forever. For now, the discovery of DMS on K2-18b is one of the most exciting moments in the search for life beyond Earth. It's a tantalizing glimpse into the possibility that we are not alone in the universe. As more data is collected, scientists will work towards confirming whether this distant planet can support life, and if so, what that means for humanity's place in the cosmos. The next few years are critical in answering one of the biggest questions in science. Are we alone in the universe? The future of space exploration and human understanding. The discovery of DMS on K2-18b is not just a scientific breakthrough. It's a turning point in the entire field of space exploration. For years, scientists have been scanning the cosmos for signs of life, and each step forward has brought us closer to understanding whether we are truly alone in the universe. The fact that DMS, a molecule typically produced by life on Earth, was detected on a distant exoplanet 124 light-years away, is both thrilling and unsettling. As this discovery continues to unfold, the future of space exploration hangs in the balance. Are we finally on the brink of discovering extraterrestrial life? Or is this just another tantalizing clue that will lead to more questions than answers? The stakes are incredibly high. If the presence of DMS on K2-18b is confirmed as a biosignature, it would fundamentally change the way we view our place in the universe. It would open up new possibilities for exploration, new questions about biology, and even new ideas about how life could exist on other planets. However, the process of confirming the existence of life on K2-18b will take years. While the detection of DMS is a strong signal, scientists are cautious and know that more data is needed before any definitive claims can be made. In the coming years, the world will be watching closely as astronomers and biologists work together to uncover the truth. But as exciting as this discovery is, it also raises a multitude of ethical, philosophical, and scientific questions that humanity is just beginning to grapple with. For one, how would the discovery of extraterrestrial life on another planet change the course of human history? Would we be ready to accept that we are not the only intelligent beings in the universe? The implications would be staggering, affecting everything from religion to geopolitics, from our understanding of biology to the way we explore space. And if life does exist on K218b, what form does it take? Is it microbial, like the plankton on Earth that produced DMS, or could it be something more complex? These are questions that scientists are racing to answer, but the unknowns are vast and the road ahead is long. But there's more at stake than just the discovery of life on K218b. The search for life beyond Earth is a race that involves billions of dollars, thousands of scientists, and an international effort spanning decades. The discovery of DMS on K218b demonstrates that our ability to study distant planets has reached new heights, and with it, the potential for even greater discoveries. The James Webb Space Telescope has already proven its worth, but its full potential has yet to be realized. As it continues to gather data from K28b and other exoplanets, it will undoubtedly push the boundaries of our scientific understanding. In the next few years, we could learn more about distant worlds, about the conditions that allow life to thrive, and even about the possibility of finding habitable planets elsewhere in the galaxy. The technology we are developing to study exoplanets will not just benefit our understanding of space, it will have practical applications here on Earth as well. Innovations in telescope design, data analysis, and space exploration will spill over into other industries, from medicine to technology, and could lead to new technologies that benefit humanity. The search for life beyond Earth is not just about answering one of the greatest scientific questions of all time. It's also about expanding our knowledge and advancing our capabilities in ways we cannot yet predict. With the launch of the James Webb Space Telescope and other space missions, humanity is poised to unlock the mysteries of the universe in ways that were once the stuff of science fiction. As we look to the future, the discovery of life on K218b could be just the beginning of a new era in space exploration. But for now, the question remains, how far will we go to confirm the possibility of life on other worlds? Will we be able to find the answers we're looking for, or will the journey lead to even more questions? Only time will tell, but one thing is certain, the stakes have never been higher, and the possibilities are endless. The road ahead for exoplanet research. As exciting as the discovery of DMS on K218b is, the journey to confirm extraterrestrial life is far from over. The next steps in this scientific investigation will be critical, not just for the future of space exploration, but for humanity's understanding of life in the universe. While the detection of DMS is a promising sign, it's just one piece of the puzzle. In the coming years, astronomers will continue to monitor K218b, gathering more data to determine whether the DMS is truly of biological origin or whether it could have another explanation. This research will take time, but it could lead to breakthroughs that change the way we view the cosmos. One of the most exciting aspects of the ongoing research is the potential for future space missions. The James Webb Space Telescope has already made significant strides in exoplanet research, but it is just one of many tools scientists will use to explore distant worlds. In the coming years, missions like NASA's James Webb and other telescopes could provide even more detailed data on the atmosphere of K218b and other exoplanets. If DMS is confirmed, it could open the door to studying other planets with similar conditions, allowing scientists to look for even more signs of life beyond our solar system. But as we look to the future, it's important to recognize that the search for life on other planets is not without its challenges. The vast distances between Earth and the planets we study mean that collecting data takes time. Lots of it. Even with cutting-edge technology like the James Webb Space Telescope, it will take years, if not decades, to confirm whether the DMS on K28b is indeed a sign of life. Furthermore, there are many other factors that could complicate the search. For example, even if DMS is present, it may not necessarily mean that the planet is habitable. Life on K218b, if it exists, could be vastly different from anything we've ever known. Scientists will need to study not just the chemical signatures, but also the planet's conditions, its atmosphere, and its environment to determine whether it's truly capable of supporting life. The road ahead for exoplanet research is one of discovery, but also of uncertainty. As much as we hope to find life beyond Earth, we must remain cautious and patient. The universe is full of surprises, and what we find could challenge everything we thought we knew about biology, space, and the nature of life itself. As scientists continue to explore K28b and other exoplanets, they will likely uncover more tantalizing clues, but they must be prepared for the possibility that the answers may not be as simple as they seem. For now, the world will be watching closely as astronomers continue their work. The discovery of DMS on K218b has already captured the imagination of scientists and the public alike, but the next steps in this investigation will be even more critical. In the coming years, we may discover more planets like K218b, planets that could hold the key to understanding life beyond our own world. Or we may find that K218b is unique, a one-of-a-kind world where life exists in ways we never expected. One thing is for sure, the search for life beyond Earth is just beginning, and the possibilities are endless. Could we find alien life in our lifetime? The next few years will be crucial in answering that question, and we're closer than ever to discovering the truth. As we continue to look to the stars, we can only wonder, what will we find next? As the search for life beyond Earth continues, we're entering a thrilling new chapter in space exploration. While there's still much to uncover, the discovery on K218b has brought us one step closer to answering one of humanity's greatest questions. What do you think? Are we on the verge of confirming extraterrestrial life? Let us know your thoughts in the comments below, and don't forget to like, share, and subscribe for more exciting updates from the world of space science.